Alright guys, welcome back, and today we are looking at bearings in trigonometry. Now I just want to caution you guys when you're doing your research online, because there are essentially two types of bearings, and there are straight bearings which involves the use of the protractor. We're not using the protractor at all in bearings in trigonometry. So when you're doing your research, make sure that you're researching bearings in trigonometry or bearings and trigonometry, because straight bearings is a little bit different from this. And as far as this topic goes, we only need a pencil and a straight edge when we're drawing the diagram. So again, as far as bearings in trigonometry goes, we're only going to need a straight edge and a pencil to draw the diagram. There's no protractor involved. So when you're researching online bearings in trigonometry, make sure that it says bearings in trigonometry and not straight bearings, all right? Or just bearings alone, because you can get confused. So we are dealing with bearings in trigonometry. Now, the position of an object relative to another is referred to as its bearing. Now, we're going to get back to that point in a little bit, so you can see clearly what we mean. But before we actually touch on that a little bit, we have to visit some very, very important key notes on bearings in trigonometry. So there are essentially 7 very important points that I need you guys to note as far as this topic goes, bearings in trigonometry. Now, the first one says bearings is measured using 3 figures, example 0.45 degrees. So if, for example, a bearings happens to be, for example, 0.33 degrees, if you put just 33 degrees, you're going to be incorrect, because bearings must be given in 3 figures. So you can't say 11 degrees, it would have to be 0.11 degrees. All right, so bear that in mind. And as we get into the examples, you're going to see more of what I mean. All right, the next one says bearings is measured from the north line in a clockwise direction. So for example, envision the clock at 12 noon, and as far as bearing goes, bearing is measured from the north line in a clockwise direction, going around like this, never anti-clockwise. So bearing is measured in a clockwise direction, going around like this from the north line, and this would represent the north line. All right, so bearing is measured from the north line in a clockwise direction, going around just like that. All right, so we're going to get back to that in a bit as well. So we're just going through formalities and explaining some critical things as it pertains to bearings in trigonometry. North lines are always parallel to each other. In some questions, you're going to have more than one north line, and when you do that, the north lines must always be parallel to each other. They can't be slanted like this. So if these are north lines, they must be parallel to each other, depending on the question, because some questions only have one north line. You don't have to worry about that. But as you get into the topic, you're going to realize that there are some questions that have 2 north lines in it in terms of the solution, and they have to be parallel to each other. They can't be slanted like that, and you're going to see that. Okay. Alternating angles and supplementary angles are very important in this topic. Extremely, extremely important. And we're actually going to be just revising that, because this is something that you should have known before, but we're going to go through that. Okay, bearings and direction are related, but they are not the same. We're going to see what we mean in a little bit with that as well. Bearings and directions are related, but they are not the same. Now, the word from in bearings and trigonometry is very important, and as I said before, when you get to the questions, you're going to say exactly what I mean. And very, very important, the compass rose or directional compass is an extremely useful tool in this topic. As a matter of fact, whenever you're going to do a question, make a sketch of the compass, which is this. It's called a compass rose. It will help you significantly with bearings in trigonometry questions. Believe you me, make a sketch of this. It will help. And when you're doing the questions, you're going to see exactly what I mean. So let me just touch on this in a sec, and just going to reiterate some of the points that were mentioned in the notes. Now, here is the compass rose, and you can clearly see here that we have north, south, east, and west. So, north, northeast, east, southeast, south, southwest, west, northwest, north. All of those are directions, of course, as you should know already. So north is a direction, south is a direction, northeast is a direction, east is a direction. All of those are direction. Now, in blue, we have the bearings now. So the bearings refer to the degrees. So note that a direction of northeast has a bearing of 0.45 degrees. So it starts at north, where we have 0, 0, 0 degrees. Remember, bearing is measured using 3 figures. So a direction of north has a bearing of 0, 0, 0 degrees. I'm going to get back to the 360 in a little bit. So as we go around here in a clockwise direction, the bearings increase. So northeast, the direction northeast has a bearing of 0.45 degrees. The direction of east has a bearing of 0.90 degrees. And a direction of southeast has a bearing of 135 degrees. A bearing of 180 degrees has a direction of south. A bearing of 225 degrees has a direction of southwest. A bearing of 270 degrees has a bearing of west. The direction of northwest has a bearing of 315 degrees, and it comes back around to 360 degrees. So when we say direction of west has a bearing of 270 degrees, that's what we mean by they're related, but they're not the same. So if the question asks you for direction and the direction is west, don't say 270 degrees, state the direction, which is west. And if they ask you for the bearing, then it's supposed to be 270 degrees, make sure you state 270 degrees and not west. So whatever they're asking you for, direction and bearings are different. Bearings refer to the angles that must be given in 3 figures, and the direction is different. All right. So that's what I mean by they're related, but they're not the same. So each direction has a particular bearing, and each bearing has a particular direction. All right. So this tool here must be drawn every single time. Make a sketch of it, top of the page, somewhere on the page before you actually start the question, because this helps you avoid making errors. So very important tool in this topic. All right. Okay. Now, next thing I want to touch on is a revisit of what we mean by alternating angles. And alternating angles are also referred to as Z angles. Very, very important angle here. So, for example, alternating angles, Z angles, is formed when you have two lines that are parallel to each other. Must be parallel, it can't be slanted like that, must be parallel. So you can only have alternating angles if you have two lines that are parallel to each other, and a line, a transversal line that is cutting the parallel lines. So whatever angle is here, let's call it theta, then it would be the same angle alternating on that side of the transversal line. So that's what we mean by Z angles, and you can clearly see the Z here, but again, you can only have alternating angles when you have a transversal line. In this case, it's this line cutting two parallel lines. All right. Now, the reason why I've drawn it this way in figure 2 is because as far as bearings in trigonometry goes, this is the orientation you're going to see it in more often than this. As a matter of fact, almost all 100% of the times you're going to see it like that. So again, whatever angle is here, if this angle here is theta, then this angle here is also going to be theta. And you can clearly see the Z there. Now, what is also important to note is that these two lines here, remember we said that this is what the diagram we look at very often in bearings and trigonometry. So these two lines here would represent the north lines, and you're going to understand when we get to the question what we mean. These two lines here would represent the north line, and they would have to be parallel to each other. All right. So just emphasizing some of the points brought up in the notes. All right, and here we have supplementary angles. And supplementary angles are what we call angles on a straight line. Very, very simple. So for example, If this angle here is 150 degrees, then this angle here would be 30 degrees. All right, because the sum of angles on a straight line must always add to give you 180. Similarly, if this angle here is 60 degrees, then this angle coming around here must be 120 degrees. So those two angles will be up front and center in this topic called bearings in trigonometry. So we're just going through some preliminary notes, and you're to make notes as well before we actually get into some questions. So when we meet again on the next video, we'll start some very simple questions on bearings in trigonometry. So I hope you found this video insightful, and I'll see you guys on the next video.